This is the 2015 ordinary level question B2, which looks at axonometric projection. Like all the other axonometric projection questions that appear in past papers, they all follow much the same setup. You're given an elevation and a plan, and it's usually something that is rectangular block, something like that, that has a circle or semicircle that needs to be taken out of it or drawn into the axonometric view. So just having a look at the question, the 3D graphic on the right shows a dog kennel. Figure B2 below shows an incomplete isometric projection of the kennel. The elevation and plan of the kennel are also shown in their required positions. So part A of this is to draw the given equilateral triangle ABC and the axonometric axis X, Y, and Z, standard for this type of question. Part B is to draw the elevation and plan positioned as shown. Again, this is a standard type of these questions. Part C, draw the axonometric projection of the sides and the roof of the kennel. Finally, part D, draw the axonometric projection of the front of the kennel to include the semicircular opening. So these questions are out a total of 45. Part D is worth 16 marks. B and C are both worth 10, and you get 4 marks for presentation, neatness, that type of thing. So let's have a look at the question sheet. So I have set up the crow's foot with my X, Y, and Z axis, and I'm going to locate points A, B, and C. So point A is the line AB is 106 millimeters long. So this Y-axis splits that in half, so 53 millimeters either side. Now I have positioned this point here, the center of the axis, about the center of the page, maybe slightly above center. That's going to give me enough space to draw this in plan, and also space left and right. You can maybe keep this this point slightly right of center, as it'll give you a bit more space. Now when you have these 2 points marked, so 53 here and 53 here, it's important to check that they end up being horizontal. So these two are horizontal. They're supposed to be, because they're supposed to be at 90 degrees or perpendicular to this. If they're not horizontal, I suggest you stop, restart this part of the question, make sure you get these right, as it will cause difficulties later on if they don't line up. So completing the equilateral triangle, have 60 degrees going this way and 60 degrees coming this way also. Again, these should cross at a single point up here. So we've got A, B, and C. What I'm going to do is I'm going to start by drawing the plan, and the plan is going to be positioned down here. To do this, we're going to extend, take points A and B and project them down parallel to the Y-axis. So these points are projected down along here. We need to draw a horizontal line, or a line that's parallel to AB, and I'm going to come down about 90 millimeters from where I positioned it. That should give me enough space to draw the plan, and also it'd be far enough away from the axonometric, the 3D view, that it's not going to be intersecting. That's a slight issue that I have here on this page, as it's the smaller paper, the A3 paper, but when you're using the A2 paper that they give you for the state exams, that should not be a problem. So what I'm going to do now is I projected the line from A, B, and extending the Y-axis down. Where the Y-axis intersects this line down here, which is halfway, I'm going to draw a semicircle. So the semicircle will go across and it'll touch both sides. So I need it to be touching here, and this is halfway along. From there we're going to create our 90-degree angle that we get inside in the semicircle. So from this point out that way, and same going the opposite way. These lines end up at 45 degrees because of the orientation of it. So inside in this now, we can draw our plan as given. So we have it's 70 millimeters along this way, and 50 the opposite way, and as I said, it's 45 degrees, so you can use your 45 degree set square in plan to draw our lines. If you don't want to do that, you can still just use your sliding set squares, take them parallel to the sides here, and that will do that for you also. So we also have to find the ridge line, which is halfway along it. So that's 25. Now, that completes the plan for this question. We will be finding points along here later on. Those are ones that are given to us in the given to us in the question, and we'll be finding them in the elevation later on. So that's the plan. What we're going to do now is find the elevation. So the elevation is drawn up in the top left corner. So we should have plenty of space for that. So again, what we're going to do is we're going to do much the same as what we did down here. We're going to extend the lines from A and C out along, and also the axis line, which is Z, and then out along here somewhere we are going to put in our semicircle again. So we need our line that's drawn perpendicular to the line from the Z axis. So now we can draw in that semicircle. So semicircle goes from here, comes back in and intersects the line coming from the Z axis. So it touches the point here, here, and it crosses the Z axis line here. So drawing this, joining this point to this point. And this out along that way also. So with those axes set up, what we can do now is we can draw the end view or the elevation. We are given width across the front here of 50. We're also told that there's 40 millimeters, so if it's 40 is the space, it'll be 5 on either side. So I'm going to mark them. And then we have a number of heights that we're marking up along this also. So we have got, there's a 60, which is the very top height, 40, and 30. So I'd like to put all of these heights in first, and then it's a bit easier when I'm using my sliding set squares to set them up, or to use them then to get the lines that I'm looking for. So this is the very outside of it. This line in here is part of the door for the kennel, and there also. One other point that I should have marked on this is the center point for the ridge. So that's going to be 25 mil because it's half of the 50. That's that. We can also mark the heights that we found earlier on. So that's this goes to the outside point here. Sorry, that's the bit in the middle for where our circle is going to go. The very outside widths and the top height up there. So I can join all of these points up now. I'm going to form the shape. So apex down to the side, and to the opposite side. The two outsides of it, and then the door piece here in the middle also. Now the final part of this that needs to go in is the semicircle that goes in here for the door. So have our center point, it's up along the same line that the ridge is on. Check that it is centered on either side, and then you can draw it in from there. Now, so I have the semicircle drawn in up here. and that completes the elevation, and the plan is now drawn. So we have parts A and B of this question now complete. So now we're going to have a look at part C, drawing the axonometric projection of the sides and roof of the kennel. So for this, we're going to take points from our elevation and our plan, locate them here in the axonometric axis, and that will give us the position for our object. So for this, we don't need the 45-degree sector anymore. We're just going to be using the 60-30 one. So we're going to be taking this corner point here, projecting that line down into the axonometric views, and then locating the same points. So this point here is a point view of this line down here on the bottom, so where it's sitting on the ground. So we can project those points up. That's 1 and 2. So that gives me that bottom corner down here, so I can just darken that one and make it clear as to what's happening. So that's this point. Going to do the same for the top corner, so from this point down. So if you just take one line at a time, this one here is also this point and this point because it's directly below it. So this point is going to project up. So that gives me this point and this point here. So now I've got one face of this, the left face of this kennel drawn. Now I'm going to draw the front face of this, and to draw the front face of it I'm going to be taking 1, 2, 3 points. I already have one line of them, so I have this point and this point, so I need to locate the one at the bottom here, this one, and the apex. So I'm going to start with the apex, so this line is projected vertically up. This is the top of the roof, the ridge line, so that's going to be projected down from the elevation also. Where they intersect, that gives me the apex of, or the start of the ridge in the axonometric view. Going to take this point here now also. It's projected down, and it comes from this corner down here. These are the same points here in the plan. So that's 1 and 2 there that I'm looking for. So I can join this up to the ridge. This comes back down to the opposite side. And there will be lines going across here. I'll just put it in lightly for the time being, and then later on we'll darken that in when I know exactly where the front of the door is. So I can bring them down here now, so those 2 bottom points for the front of the door, take them down. So I'm still working on that front face. These come down along here, touches off that point. Same on this side, this is projected down, cuts that line. So that gives me those 2 points there that I was looking for. So one final thing now before I start looking at the curve or the rest of the opening, I'm going to find just this line and this line here on the front. And to do that, again, it's done the same way as everything else. Line is projected down, projected up from the plan. And that's that line there. Do the same thing from the other side. Line comes down here to meet it. Give me that point there. So that's the front face complete, except for the arc that needs to go onto it. 2 more bits that we need to put on. We need to finish off both roof surfaces. So I'm going to do those now. So I already have the ridge line. The ridge line comes down along here. So let's find the back point of the ridge. That's this one. That's projected vertically up until it intersects the line coming down from the ridge. That's here. Let's join them up. And and that also gives the ridge line across the front. And now we have the back corner. So the back corner is at this height, so it's following that one down. This is that corner in plan, and that line is projected up here. That gives me, that completes the sides and roof of the kennel. So the only piece now that needs to be done is to draw the axonometric projections of the front of the kennel to include the semicircular opening. So we've already started that, we've got 2 lines on it, now we just need to put the curve part onto this also. Now for the final part of this, we're asked to draw the axonometric projection of the front of the kennel to include the semicircular opening. So to do that, we need to break this curve up into a number of parts. So prior to this, for all the parts of the kennel, we had different points on each of the corners, and each of those corners, it was a physical point. We don't have any points on the curve except for maybe this point here and this one, where it changes from being the straight line into the curve. So we already have those 1.1 and 0.7 there. What we need to do now is we need to locate a number of other points along this. We have the top point, so we can use that one, but that wouldn't be enough. 1, 2, and 3 points would not be enough to locate the curve accurately. So what I'm going to do is I'm going to divide this up with into 60/30. You can use your set square if you want. I'm just going to use the protractor. It's a little bit quicker for this because you're not dealing with something that's already at an awkward angle. So just joining from the center out to those, it's going to divide this up and locate the points that I need. So that gives me a number of points here. So 1, 2, 3, 4, 5, 6, and 7. It's important that you label all of those points just so that it's clear as to what's, you don't get confused when you're moving points in a moment. So 1, 2, 3, 4, 5, 6, 7, we have all of those points. Now what we need to do is we need to locate these same points down in plan so that we're able to use those points then to find the curve up here. So what we're going to do for that is we're going to take the distance from the central axis out to the side. So essentially from point 4 out to point 3, what is this horizontal distance? Same from here out to 2, what's that distance? From here out to 1, what's that distance? So to do that, I'm just going to put in lines to measure off of. So I'm going to measure the distance from the central point here, 4, out to point 3, from here out to point 2. So I already have point 4, that's this one, the apex. Point 3 from that center point out gives me a distance. And as we've used 60/30, it's also going to be the same distance that 5 is. So you can check that there, same distance. So this is point 3 and point 5. Point 2 is done the same way, so from the center out to point 2, which is also the same distance as point 6. So I'm marking point 2 and point 6 here. Now 1 and 7 are done the same way. Now you don't really need to do that as we've already that done, located up in the elevation, but we'll mark them in anyway for completeness. So 1, 2, 3, 4, 5, 6 over to 7. So what we're going to do now is we're going to take each point in turn. So point 2, I'm going to project that from the plan, project that up, project point 2 from the elevation down. Where they intersect, they are going to be the points that's going to give me the location point that I'm looking for. So point 2 is projected up. So point 2 is projected up along here. It's projected down from the elevation, and where they intersect gives me a point that I'm looking for, point on the curve. So that's this point, that's point 2, that's point 1. Point 3 is done the same way. Point 3 is projected up, and it's projected down. So that gives me 0.3. 0.4 projected up, so it's on this line from to the apex. That's 0.4. 5 and 6 are projected the same way also. Now they're going to appear to be in line with each other coming down along here. So 5 and 6. Once we have all of those points located, draw the best curve that we can that will touch off each of those points. And that gives me that front curve. So 1, 2, 3 all the way around. Only thing that needs to be done now is this is a door on the front of it, so we need to have a visible line going in along there. And that completes this question of the 2015 ordinary level B2.